It's been wonderful being here. My very first time. This year has been first time for me. Be surprised, but I've never been to Paris. This year has been the first time to Paris, but to Lithuania definitely, and also to Russia as well. So it's been a wonderful year traveling to new places. That's correct. Yes. I think the point I like the most is the diversity. It's just amazing to see people coming from various different fields of work within computer science. It's fascinating how computer field has grown so broad over the past about 40 years. We got .NET developers, we got UX experts here, Java programmers, PHP programmers, JavaScript programmers, front-end developers, back-end developers. Talk about anything you have. We got experts in the field, practitioners in the field, developers in the field. It's just amazing to have that interaction, I think. I'm actually surprised to know that I'm actually popular. I don't think about myself as that. I actually, essentially really enjoy what I do. And programming is something a lot more than, just a casual thing for me. I got into programming fairly late in the game in a way to think about it. But ever since I got excited about programming, it's been really exciting. And the reason it really is, if you think about programming, what drew me into programming is the math and the science like normally everybody gets into. But once I started programming, what really kept me as a programmer over the past few decades is really the art in programming. The ability to express our ideas and to be able to express it in so many different ways is just simply amazing in my opinion. For example, if you talk to somebody who writes a poem, for example, there is no one way to express a thought. Maybe it's a love or a tragedy or a comedy, doesn't matter. But there are so many ways to express it. Well, that's exactly about coding. You can write a piece of code, and then you can refactor it. You can make it more elegant. You can write an imperative style. You can write a functional style. There's so many ways to write an imperative, so many ways to write it in functional. And that just excites me, to be able to write a piece of code and then evolve it. And then, of course, create something of value is very exciting. And that excitement, I think I'm probably wearing on my sleeve. And so people see that I get excited, and they get excited seeing me getting excited. So I think that's kind of the, excitement is contagious, I think. It is passion, and it's a beautiful field. I don't know if I would be passionate being a dentist or passionate being an accountant. Nothing wrong in those professions, but to me, there is this excitement, an element of excitement, where you can take an idea, an algorithm, or a logic, or a problem, and be able to express it, and then to take something that is pretty lifeless, like a computer, and be able to do something with it. That just amazes me. I actually was finishing my high school probably in the early years of college, so it's pretty late in the game in my opinion. I was not one of those 6-year-old kids getting excited about programming, certainly. I was probably about 18 or 19. I didn't know anything about programming, and my uncle, who is a professor of English actually, asked me actually to solve a problem. It was actually a sorting algorithm, little did I know, and gave me a problem and said, go figure out a way to solve this. And I was struggling with it and trying to find an answer, reading about it. And then once I found a way to solve it, with the help of books and various other things, of course, when I went back and showed him the answer, he was very, much encouraging me to go explore further. And for all practical purposes, almost every single one of the people that I knew, my teachers, my friends, my family, everybody thought I was going to be a mechanical engineer. And then I got really excited about algorithms to begin with and problem solving. And so when it came time to select a major, I randomly said, I'm going to be in computer field. And it was relatively new at the time, at least back when I was studying. And so I got into computer science and engineering, not just pure computer science. So I focused a lot on hardware and computer architecture. And when I went to get my master's, it was more in electrical engineering, but I did quite a bit of work related to computer still. And then when I decided to go get my PhD, it was more into related to algorithms and data structures. So that's been really exciting for me. And I didn't really get into hardcore programming until much later. But then I started teaching. You know, when you're in graduate program, when you're working on a PhD, you got to support your way somehow. And I was actually a system administrator. So my job was to install operating systems and computers. And you know, I was a very thin guy as a young graduate student. The machines were really heavy. And I remember being a graduate student, installing these machines late in the night. I was married at the time. My wife would come to school with me. She would sleep in my office while I spent the night installing these machines. And I desperately wanted to get out of being a system administrator. And that's when the department decided to offer a course on C++. And they wanted to find somebody to teach C++. A faculty member decided to teach it, and I volunteered to teach it. And this is when the luck and miracle happens. He said, heck, if Venkat is going to teach it, I'm going to let him teach it. I'm not going to teach it. So I became the only person to teach C++. C++ was relatively new at that time. And I didn't know anything about programming C++, but I was so desperate to get out of being a system administrator. So I worked through the night learning C++, and I offered the course. And everybody said, this is an amazing course. How long have you been programming in C++? I said 2 weeks before you started programming in it. But that really caught my attention. I really enjoyed you know, explaining certain complex ideas. And I realized that I have a knack to bring complex ideas into simple terms. And my entire career in programming and teaching kind of started from there. So different people learn differently. And so I think the first thing is to really find out what your method of learning is. That's very important to take the time. I can certainly tell you what my method of learning is. That may or may not apply to other people. I actually don't have the ability to read for a long time. I just don't. Yeah, I have to shamefully admit, I can write books faster than I can read books. However, my formula is an hour of reading and close to about 10 hours of tinkering with code. I learned programming actually by doing programming. And it really excites me. So if I'm learning something new, I would get several books on the topic, but I would take a particular book, I would read for an hour, and when I start reading, I would start reading something, I would like, oh, wait, that's really curious. I'll get excited about it, and I would leave the book on the side and would start coding. And several hours would go by, and I would exhaust what I wanted to do eventually. Oh, let me get back to reading this book I was reading. And I would start reading, oh, okay, I've done that already. In my practical example, I flip. Oh, wait, that's a different concept. I haven't gotten to that. And I would start reading, and within minutes, of course, I'm tinkering with code. So I learn a lot by actually writing code, and so I would definitely encourage people to do. One of the things that a lot of developers are really bothered by is they really get uncomfortable doing something different than what they are used to. So it's extremely important to get out of the comfort zone, diversify a lot. I program in about 12 different programming languages. I wouldn't call myself an expert in any one of them, but my strength really is not in knowing one thing extremely well, but by knowing things literally broadly. So when I approach a certain problem or a particular solution in a certain language, my strength in finding solution in that language actually is my diversity in knowing how this works across different languages. So when I worked for a client, for example, on a C# project, I was able to do in C# things that normally C# programmers wouldn't do. And they would come back and say, that's a very different solution than what we're used to. How did you get the idea to do this? Well, I know how to do this in Ruby, and I decided to apply that using delegates over here. And similarly, when I started writing the book on Java 8, I was actually able to show in the book certain things that I've learned from Clojure and Groovy and Scala and F#. So when you bring different languages into the mix, you're able to do things that people normally wouldn't be doing. And in a way, if you really think about it, you know, I travel around the world, and I get to really enjoy the experience of working with developers from various different cultures and background. And that is, to me, my strength is the diversity of people I interact with. It's the same thing with programming languages too. The fact that I'm able to work with a dynamically typed language, a statically typed language, a language that supports different types of concurrency models, for example, one that has pattern matching, for instance, one that provides a different support for XML processing. These things broaden your view, and you begin to realize that there is simply not one way to do things. And once we realize it, we're not too eager to say, that's the right way to do. You're much more eager to explore different solutions and pick the one that may be better for a particular problem on hand. And I think that is what I would encourage people to do, is to diversify. I would never want to call myself as a Java programmer or a C# programmer. I think we should take pride in saying we are problem solvers. Because when people hire you, they don't hire you for you being one programmer. They hire you to be able to solve problems. And if I give you a problem, and if there is a better solution in a different language or a different mix, and today the beauty is, almost in every platform, we can mix libraries, mix languages. Look at the JVM, there are 200 languages in the JVM. Look at .NET platform, you could use F#, you could use C#, you could do VB.NET. There are different solutions available. So the point really is, your strength really is in solving problems. Your strength is not in being stuck with a certain language or a solution. So my first advice would be to diversify, focus on solving problems, focus on really learning and becoming diverse, and focus on just enjoying the process of solving problems, I think. The language I prefer the most is the one that solves my current problem. I really don't want to pick languages. In a way, I argue that languages to me are like vehicles. I like riding my bicycle. I like to take my bicycle, go around my neighborhood, take it to my park, but then I need my car. I have a Jeep that I would like to drive, and of course it takes me to the airport from time to time, takes me to the neighborhood stores. Of course, airplanes, I have to use them to fly across. I couldn't be here today had I used my car. And so languages to me are like vehicles. In a given day, probably a really good day for me is when I've taken my bicycle in the morning, I've taken my car to the airport, I've taken a flight to a foreign land, and to me languages are like that. So on a typical project, I tend to use multiple different languages typically, because one language may give me really a good capability for meta programming, and I may be able to employ that in areas where I need to use that, whereas another language may give me the infrastructure that's needed, static typing maybe, for example. So the strength is really in mixing languages, and as a result, I tend to really have no particular preference in programming languages. I'm going to use the words of Thomas Huxley. Thomas Huxley said, know everything about something and something about everything. And I think that is extremely important to be successful in today's world. You want to know everything about something. You want to become really an expert in one area, and the depth is very important. But we cannot become an expert in one area while being ignorant in other things. It's almost impossible to be really knowledgeable in a broad area today, especially with the field increasing. It's almost impossible. So there is a difference between knowing really well and being aware of to a reasonable extent. So for example, if somebody comes to you and says, why would you use one language over another? You must be able to at least be able to say what the key strengths of that languages are and some of the weaknesses, if you will. So I would say know everything about one language. If you're a C# programmer, sure, take the time to really know what it is to be a C# programmer. Know about asynchronous programming in C#. Know about, how do you make use of functional style in C#. Know when you should use imperative style versus functional style. Absolutely those things. You want to know about using entity framework, for example. But at the same time, though, it's important to know a little bit about, hey, what does Ruby bring to the table? What does Python bring to the table? When would I use, JavaScript, for example? What are some of the reasons? Hey, what does TypeScript has to offer? Why would I use TypeScript versus JavaScript? How is Lambda expressions different in F# compared to C# compared to Java? I think I would like to have some of those knowledge as well, so that we don't become adamant about saying C# way of doing things is the right thing to do. We are able to understand why one is better than the other, and maybe the way we do it in C# is not the better way to do. Maybe we should think of doing something a little different, and we can borrow these things from other languages. So I would say it's a two-pronged approach. I don't want to hire somebody who doesn't know a particular language enough, and I don't want to hire somebody who knows only a language very well. I think it's a balance I think we should really look for in this case. Well, I think Peter Drucker said the best way to predict the future is to create it. So I suck at predicting the future as everybody else is. But I can certainly say that there is a trend that I think we are seeing. If you really think about programming language development, object-oriented programming was created back in 1967. It took 23 years approximately for object-oriented programming to become mainstream. So in a way, if you really think about it, things change very slowly in our field. Adoption of a paradigm is a very slow path. The functional programming concepts, the underpinning behind it, the category theory and stuff like that, really came out in the 1930s, and we are just about getting excited a good 80 years later. And the first few programming languages like Lisp, for example, in the 1950s, were actually functional programming languages. So why are we getting excited about functional programming now? And the reason for that is the hardware has changed around us. Multi-core processors has made multi-threading a lot more available to us. And big data, for example, right? So when you have big data, the internet is something that has changed the world around us. People carry multiple devices with them. We are talking about handheld devices. We're talking about wearable devices. Very soon, people will be walking with tongue rings, nose rings, earrings, all internet enabled. And as a result, the world around us has changed, the computing world around us has changed, the hardware has changed, the internet has changed, availability of machines have changed. The question is, has the software programming changed to accommodate the hardware, the demands of the industry? And when you look at the demands of industry, for example, if you really think about it, Google showed us how the web can actually be rich, and suddenly organizations wanted richness in their web. That's exactly what's happening again. When you are seeing machines and devices, the companies are saying, I want to be able to make data more available, I want more interaction. Well, programming world has not changed to catch up with it. This is exactly what happened in the 60s when the business world changed and we had to really come up with the programming languages to accommodate it. So we have a rebirth in the need around us, and programmers are saying, how do I really cope up with this? Well, thankfully, the guys who did functional programming were way ahead of their times. They did all of that, and they sat back and said, kids, we'll wait for you to grow up. The world will wait for you to grow up. And to me, this is really rewarding because it's risky to do something newfangled that's not been done before, but this has been done already. And it's really a question of we using what's been around for a long time. And so I think the trend in the next about 5 to 10 to 15 years is we're going to really start using functional programming. However, I also want to emphasize, I think it's a little misguided to say functional programming is the way to do it. This goes back to what I said earlier, is we should really let go of the notion that there is one way to do things. And I think we have learned really well from object-oriented programming. We have benefited a great deal from object-oriented programming. We are beginning to see the benefits of functional programming, and we really need to learn how to really combine these ideas together. If you really think about object-oriented programming did not throw away structured programming. In a way, object-oriented programming was built on structured programming by bringing the structured programming concepts with object orientation on top of it. Now it's time for us to really bring where object-oriented programming makes sense and bring functional style programming and intermix them together. If you look at languages like C#, languages like JavaScript, Scala, Java, Groovy, a lot of these languages really bring a combination of functional and object-oriented programming together, imperative and object-oriented programming and functional programming together. So our job in the future is to really find out what is a good balance to apply these good concepts in a way to really bring the best of all the worlds together. We haven't even touched the logic programming yet. Languages like Prolog, ability to express declaratively. Functional programming is declarative, but it's a slew of declarative programming we haven't even touched yet. And logic programming is all the more declarative. We are just about learning functional programming. Who knows when we're going to get excited about logic programming? And if you really ask me, I want to live very long to see how the world changes in programming. I don't want to live long for other reasons. I just want to live long to see where the programming world is heading. I'm really excited at where we are heading. It's going to be a really fun next 10 to 15 years, maybe 20 years. Oh boy, that's a hard question. I would certainly say yes, it's grown, but not enough. It is growing. It is growing, but we need a lot more discipline than we are doing right now. I'm actually working on a blog right now, and my blog is going to be called as it's the year 1820 in programming. And I'll tell you why I'm saying it's 1820. If you look at the year 1820 in the medical industry, people were dying after surgery. And when you saw doctors perform surgery, doctors took a lot of pride in performing surgery. And to them, a success of a surgery was when the patient survived surgery. And when really good doctors perform surgery, patients would die after 2 or 3 weeks after surgery. And they would say, my gosh, the patient survived surgery, but they died. And they were struggling to find out why the mortality rate was very high after surgery. And then there are certain people who came about, and one of them was Semmelweis, and he found out that his practices were very different. He did not know why at the time, but he was washing hands with soap and warm water. He was sterilizing his devices, and when he performed surgery, fewer of his patients died after surgery. And then he said, hey, maybe there is some things called germ, and maybe by washing, we are killing those germs. And the world did not agree with him. This was days when we did not know about germ theory. He was one of the first proponents of germ theory. And then, of course, he ran into trouble. He eventually was killed, actually, under custody. And then a few years later, people like Jim Lister and Pasteur came along, and they took his work and said, hey, you doctors who are considering yourselves to be really great doctors, you have blood-soaked coats. In fact, doctors back then were considered to be really good doctors if they had more blood on their coat. And they said, you are actually killing your patients because you're carrying germs from one patient to another. And the doctors didn't like them. They wanted to take away their medical license. And in fact, back in the 1840s and 1850s, in England, there are stories of hospitals opening the windows to get the air out because they thought there was something in the air that really infected people. Now we know a lot more about medical practices. We no longer are living in 1850s and 1820s. We have better sterilization techniques. The programming world is in 1820s right now. We believe in writing really crappy code, getting it out. Time to market is very important for us. We don't focus on quality of code. We don't take the time and the discipline to automate and test our code. To me, the crisis in our field is lack of automation testing. The companies that are interested in doing automation testing are doing it the wrong way mostly. And I'm hoping in the next about 15 to 20 years, there are 2 things that are going to change. One is maturity of programmers. But there's another thing that's going to change. I'm already seeing this. I have served as an expert witness on at least 4 to 5 different lawsuits. Companies have hired me to come in as an expert witness to say, hey, look at this project. We have lost a lot of money on this project. Tell us about the quality of software. Thankfully, it's been very easy to prove poor quality in these cases. No automation testing, long methods, unmaintainable code, lack of really good practices that you would say as good practice in writing software. Well, clearly, companies are beginning to sue. And if you really think about it, software is no longer an esoteric field. Every walk of life now is influenced by software. You are looking at airline industry canceling thousands of flights on a day because there was a computer error. You are looking at various other fields where we are being jeopardized by poor quality software. I'm not able to get my work done because I cannot log on to a system or a computer software has failed. It is no longer a case where we don't care about software failing. It is where our lives are being impacted by poor quality software. When that happens, there are two things that are going to happen. People are going to become mature. Not everybody is going to become mature. The world is a pyramid. There are really good people on the top. The bottom is going to be really suckish, right? That's the way the world is. But more people are going to race to that pyramid to fill the top. We're going to have more awareness of people. There is also going to be lawsuits. Don't get me wrong, I'm the last guy to be excited about lawsuits. I don't like the lawyers. I don't like the way things are, but that's eventuality. And when companies are getting sued, and that's going to put burden on companies, and what are companies going to say? They're going to come back and say, we don't want to get sued. We don't want to lose money doing that. Let's focus on developing better quality software. That's going to happen in the next 50 to 100 years. And so with more maturity, with more awareness, more consequences, I think we're going to get drawn into. So in a very ideal world, I would tell you that people are going to become responsible, and some people are going to be that, but majority of the people are going to become responsible, not because they have to, but because they're going to be mandated to. But I think that's where we're going to head in this direction, I think. I would say, pay attention to what you do, care about what you do. What we do makes a difference in this world. We are a very important part of the society. We have a very individual responsibility, and this is something, it is about ethics, it's about professionalism, it's about craftsmanship. If we do not care about what we do, nobody else can. I plead to technical people, right? So when technical people say, my manager would not allow me to do, it is a shame. When there is a better way to do, it is your professional responsibility to fight for it. If you have a doctor and the doctor says, I know this is the right thing to do to save my patient, but I cannot do this because my management won't give it, we don't want to work with doctors who are not professional. My son was not well, and I took him to the doctor, and the doctor decided to prescribe a certain particular medical practice. And I was quietly listening to this, and then he said, that's what I want you to do, and he left the room and said, my nurse will come and take care of this. And I turned to my son, I said, there you go, the doctor said this, what do you think? And he looked at me and said, Dad, I don't have a clue what this means because I don't understand how this is going to help me. My son is a very smart guy, and I said, I just asked you the question because I wanted to hear this from you, because what I just saw was a total lack of professionalism right now, and I cannot believe what I just saw. Because when I come into this doctor's office, I expected a very high degree of professionalism. I am totally shocked right now. And when the nurse came in, I said, I want to talk to the doctor again, because what I just saw being prescribed is not going to help my son with the current condition. So the doctor came in and said, so you're the doctor now, aren't you? I said, no, I'm not the doctor, but I'm not also a novice. I am a person who has sense, and I can understand and put logic together, and what you just prescribed may be useful, may have a fringe benefit, but you're not solving the real problem that's underlying. And in this process, you completely eroded my trust. You are no longer my son's doctor. We are done here, and I'm leaving. And I immediately took him to yet another doctor, didn't say anything about it. And the minute the doctor looked at my son, the doctor said, oh my gosh, he's having pneumonia. He cannot go to the school for the rest of the week. Here are some antibiotics. Take him and keep him under control, and come back in 3 days, we'll take care of it. It was a completely different diagnosis. And I was able to see, I could sense, right? I'm not a doctor, but I'm not also an uneducated, right? And to me, as a professional, as a programmer, when a business comes to you and says, solve this problem, Your job is to solve the problem on hand with the topmost quality to provide value. You cannot be influenced by other things that could motivate you. And much like the professionalism I expect from my doctors, especially when my children's life are involved, that's exactly the professionalism I expect from us, the programmers. So my request for anybody attending the conference, any developer is, grow up to become a professional. Care about what you do. And if we do not make this profession really shine, nobody else can. Because we are the technical people. We understand technology. We understand quality. We understand consequences. If you and I do not care to do the right thing, nobody else can. So it's our responsibility. We have to grow up to do that.